Hello world, this is Ankit, and today we are going to look at a simple concept and a very easy to learn machine learning model which is used a lot, and that is simple linear regression, and we will implement it using Python. So for this we will use Jupyter Notebook, and I will walk you through the code and tell the basics of linear regression, and we'll look how to predict a value depending on the regression that we find out. So without wasting any time, let's get started. So there's the Jupyter notebook that we are going to walk through in this video lecture. So linear regression, the, this is mostly just a code for reference, and we have a data which is like US for the US house. So we will try to predict the cost of a house depending on certain given attributes, and suppose we have a neighbor who wants our help to get know what is the actual price of the house if some attributes are given to him or her. So is a sample data set that we have, a small data set, and in this we have these attributes which are the average house income, average area, house age, and these are the descriptions given here. So just let's get started with importing the essential libraries. So we have here pandas for the data frames for loading the CSV and changing into a data frame, numpy for the mathematical computations, and matplotlib. We use matplotlib for the simple plottings, and seaborn as well for plotting. So just import this data set, and importing the libraries, and then we go and check out our data. So basically USA housing.csv is our data, and we'll try to import this data set. Once we are done with importing the data set, we'll can use us housing.csv head to see our data, how it looks. So I'll quickly run that code, and now we can see the average area income, the income of people at an average in that area, the average house age, the age, the how old is the house there, like 5 years, 6 years, 5.86, and all. Area, average area, number of rooms per house, number of bedrooms, area, population, price, and address. So now we can use the info function to get the information about all the attributes that we have imported from the data set right now. So I run this code, and we get it like average area income has 5,000 rows, that are 5,000 entries, which no null entries, and it's a float 64. As we can clearly see, this is the float 64 data, and others are same. Now we can use the describe function to get a description of that, and simply we can know the columns that are there. So these are the columns which I have already shown. These are the attributes that will help us decide and fit a regression model and predict the outputs given a new input. So basically what happens in linear regression is you have a lot of data, you plot the data and into a 2D frame, and then you try to fit a line that's best fits and according to the data points, and depending on that line you give other inputs and check and plot the output for the given inputs. So there are two types of variables. One is dependent variable and the other is independent variable. The independent variables are the attributes, and the dependent variable is basically the target variable that we are trying to predict or trying to classify or something. So we'll plot simple graphs for which will help us visualize it better. So this is a basic visualization for graphs, and that's not important for the model. So we'll skip that part for now, and then we'll go to the price. What is the price? And this is the metrics, how you can see the price, the heat metrics, the most price thing, and the least one. And now we come to the main part of our program, that is training the linear regression model. So we divide our data set into x and y. Basically, x are the independent variables and the y is the target variable or the dependent variable. So in x we will have all the things that are the attributes, and y is the price what we are trying to predict. So x has all the features except the address, because address is text data and it won't contribute to our predictions. So we quickly run through this, and x has the attributes and y has the dependent variable, that's the target variable. And now we split the data into train set and test set. Basically we do this to have a train set on which the model is trained, and the best fit line is found, and the test set is used for evaluation purposes and to predict depending on the test inputs that are not being trained, and depending on the new inputs what is the predicted output of our model. And we can compare it to the test, like we have the original results, so we can compare it side by side and get whether our model has predicted, has performed well or not. You can get it from there. So basically we'll import sklearn.model selection test and train split, and this would as a useful handy function that helps us split the data. And I will take a test size of ratio zero point 0.4, like the test size will be 40% and the train for 60%. You can decide upon this, and it's not a fixed thing. So we'll create a model from sklearn has a lot of models, so our model linear regression is under the linear model, and we import it. And this is the function lm, which the linear regression, we call this function, this class we have imported, and this function we call, and it is stored in this variable, and we can use this variable to fit for the x train and the y train that we got from here: x train, x test, y train, and y test. So x train and y train are the training set, and x test and y test are the independent the test set. So basically x train is the dependent variable in the test train thing, and y train is the dependent variable in the train thing, and this is the x test is the dependent independent thing, and the y test is the dependent in test and train. You can understand it. Yep. So now as we have imported the model, let's store it into a variable and do the fit, and we have done our model fitting on the test train data set. And now we move on to model evaluation. So how good is our model? So what is the best fit line is just a line that passes through. So we can get the intercept of that line, and through that intercept we can also use that intercept to see whether which attribute contributes to our data most. So here we used coefficient pd.data frame and the coefficient thing to get the difference. So basically for one, what it shows is for 1 unit increase in the average area income, the increase in price would be of $21. The average unit increase of in the average area house age, it would affect the price of the price of the building by this 16400 something. So basically this is a self-made data, so it doesn't make any sense, but for a good data such as the Boston data set, I would recommend you can test it there. It's a good data set and it's on a real world data set, so it would give a more valid predictions. So here now what we do is we try to predict on a model, and for the x test that is the test set, and hence this is like the predictions we have stored it here, like for all the like 40% of the data set, all the things we have the predictions here, and using matplotlib, the scatter plot, we'll make a scatter plot of that and visualize for visualizations. This is what we get it. And then after we have predicted our thing, and then for we can do the predictions for an individual input as well. So it's very easy. You just need to do this lm.predict, and you just need to pass one tuple which consists all the attributes that you are like the age of the house, the number of rooms, the income and all, and it will predict whether what will be the price. So basically, it is regression is different from classification, because regression is basically giving you the depending on the best fit, it predicts what will gives the output, like the quantity, how much the amount would be the predicted price or something. Classification is basically like classifying depending on whether it belongs to this class, this label, or that label. It's basically there. Now we move on to evaluation matrices. Basically, evaluation matrices help us evaluate which of our like how wrong we have done in the model, and how our model does. So basically, this is the evaluation matrix. There are three basic types of evaluations, and first one is mean absolute error. The second one is mean squared error, and the third is the root mean squared error. So means absolute is nothing but you can see here the difference between the mean yi dash and yi is the observation, the current observation, the summation of whole divided by n, and this is the mean squared, just squaring that thing, and root mean square is root. So basically what we use is root mean square, that is used the most, and it is like it is more interpretable to the y units, and it gives a like good result, and you can like cross check it for. So basically all these are nothing but our loss function, and we tend to minimize them. The most minimum is the better. Okay, so we from sklearn we import matrices, and for all the matrices we try to find mean absolute and mean squared and root mean squared. These are very simple codes, and here we go. So basically this is the deviation, like this is the loss function. So that's it, that's pretty much it, and that was so simple, and great job. We have completed a simple linear regression model, and though it is a very simple simple model, but it's like basic machine learning model, and it comes in handy in a lot of places where the number of dependent variable is just one. For number of dependent variables increasing to 2 or more, we have multiple linear regression instead of simple linear regression, and we have logistic linear regressions, which we'll be seeing in our future videos. And thank you for joining me, and have a great day ahead. Until then, happy coding.